In this problem, a drink can is a cylinder with a radius of 3 centimeters and a height of 12 centimeters. Sketch the can and label its dimensions. Alright, well let's do that. To sketch a cylinder, I start with a oval-like circle for my top. I try to match it for the bottom, just a sketch. And then I draw these lateral lines right here. So these lines right here represent the height, h, and that equals 12. Right, you always want to keep track of that. And then the radius, center points here. Some line from the center to the edge is the radius of 3 centimeters. Okay. And I'm just having a hard time drawing this straight, I'm sorry, but I'll leave it. It is a sketch. Okay, got that. What is the circumference of the can? Well, the circumference is the distance around one of the circles at the base or the height. So here, to find circumference, we use our formula. Circumference is always about 3 times longer, or pi times longer to be precise, than the diameter, or pi times 2 radiuses. 2 radiuses is equal to the diameter. So here for circumference I would write 2 times 3, which is 6, right, double the radius, times pi in this order. 6 pi, but we're dealing with centimeters, so 6 pi centimeters. You could expand that if they ask you to round it or estimate to 6 times 3, or about 18 centimeters, but 6 pi centimeters is the most precise we can get. What is the volume? Well, we want to find the area of the circle on the base. To do that, right, we take the radius and square it to get 9, and then multiply that by pi, right? That's the area of the base, or pi r squared, right? That's the formula we're using. I'll write it over here. Or I wrote it as r squared times pi. Radius is 3. Square it to get 9 times pi, and this is, right, centimeters squared, square centimeters. It's the area of the base. But we are concerned with the volume. So that base times the height. So we take 9 pi square centimeters times the height, which is just 12 centimeters. And this gives us a volume. Centimeters times centimeters squared is cubic centimeters. 12 times 9 pi is what? Well, I'm just going to do 12 times 9. And then to figure that out, I made a mistake with this before. 9 times 10 is 90. 9 times 2 is 18. I put 118 before. Don't be quick on that one. It's 108 pi, right? So 108 pi cubic centimeters, right over here. 108 pi cubic centimeters. That's our volume, V. So anyway, 108 pi cubic centimeters, it's about 3 times 108 cubic centimeters, but you can leave it in terms of pi. It makes your life a lot easier. What is the surface area? Well, there are 2 circles that make up the surface area. They're both equal in the cylinder. Each of them has an area of 9 pi. We already figured that out, so TSA, total surface area, equals to 2 circles, 2 times 9 pi, and those are each square centimeters, plus this lateral surface between, right? And it goes all the way around the shape. If you unfold it, you can think of unfolding a towel roll or a toilet paper roll or any curved paper. If you unroll it, just like with wrapping paper, you get a rectangle. So this middle surface in the cylinder is really a rectangle, and the surface of it is the area of it. So the height is 12, and the width is the circumference of the circle, right? Because it has to wrap around the circle. So we found the circumference. Well, what is that? We said it's 6 pi, and we know the height's 12. So that's going to be 6 pi centimeters times 12 centimeters, right? Because that's the area of that rectangle. So we can simplify. 2 times 9 pi is 18 pi, right, square centimeters, plus, well, 12 times 6 is 72 pi's, square centimeters, right, centimeter times centimeter is centimeter squared, or square centimeters. Add them up, and what do we get? Well, what's 72 pi's and 18 more pi's? Well, that's 90 pi's, right? 72 plus 10 is 82 plus 8 is 90 pi's, or 90 pi square centimeters. That's our total surface area. Now the last one, and all we're doing there is adding up all the faces to the shape. That's always the strategy for surface area. Now this last question, they say, how many cans will it take to fill a liter bottle? Well, a liter bottle contains 1,000 cubic centimeters. So really it's time to estimate. Because we want to divide 1,000 by 90 pi. How many times, by the volume, 108 pi. How many times does this volume go into this volume over here? So how do we do this? Well, first we've got to estimate the volume, I think. I'm going to say pi is about 3. And we can estimate to all types of numbers like 3.14, but I'm going to just round it to 3. So 108 times 3 is what? Well, 3 times 8 is 24. 3 times 100 is 300. Add them up, 324. So the volume of one can is about 324 cubic centimeters. But we're dealing with 1,000, right? So let's just divide. 1,000 is the total number of cubic centimeters in a liter bottle. So 1,000 divided by 324, we get this number, 3.086419. So what does that mean? Well, that means that 3 cans won't be enough to fill up a liter, right? Because it will take a little bit more than 3 cans to fill it up. So in order to fill an entire liter bottle, I'll need at least 4 cans to do it. Because 3 cans comes up just a little bit short. Because here we're saying, well, divide 1,000 by 1 can and see what happens. Well, you need at least 3 cans to fill it, 3.08641975 approximately. But you want to say, okay, well, since we're trying to fill this container, we'll need more than 3 cans. So I would say you need to go get 4 cans to fill this bottle up. It's all about how you estimate. For example, let's say I approximated pi to 3.14. Well, then the volume would be 108 times 3.14. So 3.14 times 108. In that case, we get a different number. Instead of 324, we get 339. Well, this is a more accurate number. And what that means is now we take 1,000, right, divided by, we'll just 339.2. We're doing the same calculations with a different estimation. And now we get a number that's less than 3. So the more accurate number you use for pi, the higher the precision of your estimation, the better your answer. So when we rounded pi to 3, the answer to this problem is that you need more than 3 cans. But if you estimated 3.14, the answer is, well, here 2.9 cans would fill it, so you could just fill the entire liter with 3 cans. So what's right and what's wrong? Well, this is more correct than the last answer. However, it depends how far you round pi. Now, they don't tell you how far to round pi. Be as precise as possible. But if you're on a test or in a class, or make sure you understand exactly to what degree to estimate pi. And the goal is to be the most accurate as possible. So if you have the tools or the time to round pi to a more approximate number than just 3, then use 3.14 or 3.14159 or some better approximation. So actually you could say E here that the answer is 3, as 3 cans would fill the liter as well. Thanks.